Hello, everyone. My name is John Velissarios. I'm Accenture's Global Blockchain Technology Lead. I'm based out of London. I've been with the company for 14 years. But in the last 3 years, I've done something a little bit different in my career. I just want to give a quick introduction about what I've done and why I did it. About 3 years ago, I stepped out of my day-to-day job. I had a great job at Accenture. I loved it and everything. But I saw something around the corner that was going to transform what I think is going to be IT, technology, business. I took a leave of absence from the company and I joined a startup for about a year and a couple of months. And in that startup, I experienced the sort of the change that is about to, I think, going to happen, is happening now, so which I'll talk about today. Came back in the company and I then started working on a number of blockchain projects. I am actually leading several of these engagements, both from the selling of those engagements through to the delivery of those engagements. I'm a solution architect for many of those projects. And part of my great job is to come up and talk about what I do in conferences such as this and events such as this. So one thing I do want to talk about actually is there's quite a lot of stuff that's happening in blockchain. But I want to set the stage because there's a lot of misconceptions. And I want to just explain sort of what it is and what it isn't. I have a couple of slides that talk a little bit about that. Sort of fairly basic slides, but if you take a look at them, at the end of the day, on the left-hand side you have traditional IT technologies, databases, firewalls, networks, and you have a hard shell and a soft center typically, and you protect everything in aggregate form. With blockchain it's quite different because what you're doing is you're having a same copy of the data everywhere. So it's a replicated data store that's copied amongst a number of participants. Members of an ecosystem, and the data is the same. So every single one of those blue circles that you see is the same information that is replicated amongst each of the different nodes. So every member of this ecosystem has a complete copy of every transaction that's taken place, every message that was sent, and you can do things like sharing and mutualizing information, which I'll talk about a little bit more. And you protect everything at the data level. So you're not protecting the firewall, you're not protecting the network, you're not protecting the database, but you're protecting it right down to the data element level, and hence you can encrypt it by identity of the participants that are part of that. There are a couple of different types of blockchain implementations, and one thing that you probably have heard a lot about is sort of Bitcoin and cryptocurrencies and so on. That's where a token, whether it's a currency like Bitcoin for instance, or other types of tokens, are exchanged between participants. So on the left you have a sender and on the right you have a receiver. You're sending the message and you're sending a token, and the message is embedded in, the token is embedded in the message. And at that point you have an asset that's being moved from one person to the next. You can actually do a couple of clever things. You can strip the token from the message and you can just send the message. You don't have to tokenize assets. You don't have to move bitcoins around. You don't have to move cryptocurrency around. Actually, you can do a lot of different things with this technology that have nothing to do with money or currency at all. And so we've been involved in implementing a number of projects that do exactly that. We've built financial messaging applications. We've built other types of messaging applications that use this technology that have nothing to do with the currency and have nothing to do with tokens. In addition to that, you'll also see that you can use this technology for doing things like sharing and neutralizing information. And by that, we mean sort of having a single repository, a single store of information where multiple participants can exchange information, can contribute, and then receive the same information, like in a similar model that I described on the previous slide. Now this is very important because what you can do with this is you can use this technology to do something completely different. Exchanging information, you can do lots of collaboration, you can use it for tracking things, you can use it for all sorts of applications, which I'll talk about in the upcoming slides. So what's the hype? Why all this, why the excitement about this? At the end of the day, the whole idea behind this technology is that it can transform traditional IT systems, databases, networks, messaging, into something that is very straightforward, and it is by sort of membership, and I'll discuss what that means in a bit. But the information is basically in the blockchain, in the ledger, and the participants, as many participants that are allowed in to this ecosystem, can see this information and even see parts of the information as well. Now, in all of our experiences, when we talk about sort of blockchain and distributed ledger technology, we typically talk about private and permissioned systems, so not open and permissionless systems. And by that, like Bitcoin as an example, is a permissionless system. Anybody who can access it, can use it to do whatever they want with it, mine, and also be sort of using it as a currency and moving money around. But in all the applications, at least in an enterprise model that we've been using, in a government and corporate model, have always been permissioned. In other words, you have to be sort of authorized to create create blocks and access the ledger as well. So that's a bit of a distinction. One big application of this technology is in the space of reconciliation. There's a lot of applications in traditional sort of back office organizations that require lots of reconciliation. Financial services is ripe with this all this reconciliation function, be it things like regulatory reporting or any transaction reconciliation. So if you take a look at sort of this is an exchange environment where you have a financial ecosystem. You have buyers and sellers, and then you have a whole bunch of intermediaries and exchanges in the middle and central counterparties and so on. Every single one of those circles basically records transactions as they're being published or pushed from left to right and right to left. So when a buyer and a seller agree to buying and selling a share for cash, what happens is that all the intermediaries along the way create a record that is actually recorded in each one of these databases. This record then needs to be reconciled, and that is a huge overhead. We actually have a number of publications. A couple of months ago, we wrote a white paper, a point of view, on the amount of the cost associated with performing this back office reconciliation. For some of the big banks, and the savings or the cost associated with that is significant, in the billions of dollars for a couple of institutions. So if you take a look at this example, what you see is that even lots of internal reconciliation within a department, cross departments, cross institutions, and then even with regulators, and all of that creates a huge amount of overhead. If you had a single ledger where you wrote all those transactions to, and you're able to record those transactions, then you can do some clever things, because you can now take the cost or the burden of reconciliation away from this kind of application. So in a blockchain world or a distributed ledger world, what you're doing is you're basically allowing the ledger, the same one ledger that everyone sees, to contain all the transactions. So firm, buyer, firm, the transaction cost, and so on. And you can lock it down by field, so only specific entities can see it. For in this case, sort of you see the regulator can also see the transaction, but nobody else can see that information. And so there are specific ways that you can manage all that. But what it does is it means that you no longer need to have large data stores in each of the different organizations and having to then extract information to perform reconciliation and so on. So there's a lot of applications. We have seen a lot of interest and also projects where we've been working with financial institutions to take the cost and the burden of reconciliation out of organizations and the back office function using this kind of technology. So what I talked about at the beginning was sort of the messaging, so the tokenized movement of assets, and also the messages that move back and forth. The example that I love to give is selling sort of share certificates, or selling shares rather. So I have my Accenture shares, and every once in a while I decide to sell them. And I go to my broker-dealer site, and I click the amount, and I hit sell, and it's a very liquid share, so it instantly gets sold. But the money takes about a week for it to come into my account. And so what's happening today is that there are a lot of very optimal matching engines, execution engines, and so on, but the whole aspect of the settlement actually takes a long time for it to complete. So the whole end-to-end process is suboptimal. The actual parts of it are, but the end-to-end isn't. So what this allows you to do is to actually decouple the asset movement and the money movement from the messaging. And what you can do is you can say, well, I'm going to sort of send all those messages or all those exchange transactions and so on, and then I'm going to net those, and I'm going to compress them, and then I'm going to trigger the settlement process where I can then move the money in real time. The key part of this sort of, the thing I want to deliver out of this sort of message here is that optimal settlement doesn't have to be instant. Settlement can take place at an optimal point in time for the business. It can be daily. Today it's daily for many organizations. It could be hourly, it could be based on risk, it can be based on value, on volume, or whatever. So you decide what is optimal for the business using this kind of mechanism. But the thing is that I guess now you can actually do that whole delivery versus payment. If it needs to be real time, it needs to be instant, you can do that. If it needs to be based on sort of transaction volumes or values or risk exposure, then you can also do that as well. And now you can do it in a single atomic transaction. So the beauty about this technology is that it allows you to deliver an asset and also get paid for that in a single atomic transaction. And that eliminates the need for things like escrow accounts and complex risk that's associated with all of these transactions that have a premium associated with it. So those are a couple of examples, and those examples I could have given, I could have replaced an exchange with any other type of institution. We've looked at this from in the aerospace industry, the travel industry, government applications, and so on. The same sort of symptoms or problems we see over and over again. So I get a lot of requests, why can't we do this on the blockchain, or why can't we do that, why shouldn't we, or could we look at this, and so on. So there are a lot of use cases for this technology, and there's many things that it's good for, and there's many things that it's not that good for. And this is sort of the criteria that we typically use. So this is sort of the acid test of whether an application or a use case is a good one. So if there are multiple sort of validation and control points, multiple actors involved, the need for reconciliation like I just described, the need for auditability, you need to make sure that every single record, every transaction is fully audited, auditable as well. You need to have also a view of the lineage of the data from its very beginning. So if these 5 criteria, I mean, we have a bit more of a longer list, but we've distilled it down to these 5 criteria. If these 5 criteria are the ones that you tick the box and say, yeah, that's applicable for me, that's applicable for me, and so on, if all of these are satisfied, then you probably have a very good candidate for a blockchain or a distributed ledger implementation. If none of these are satisfied, then maybe a federated database or something else is equally good or probably better than using a blockchain to do that. So it's very important to sort of differentiate. There are some very specific applications, distributed trust, basically trust models that it solves, and other things that if you have already a centralized trust in your organization and you're using it amongst a very small group of individuals or entities, then it may not be feasible. So this is just a suitability test for a blockchain and DLT technology. I want to now give you show some examples of the things that we've looked at in terms of applying this technology. And I think, first of all, before I show you the slide, I want to talk about sort of the fact that this is a very young and maturing marketplace and technology as well. And there are lots of pilots, POCs, concepts, ideas, implementations, and so on. And the slide itself talks to many different things. Here we have sort of an inventory, apologies, an inventory of applications and use cases from financial services all the way through to customer data and government applications. And these range from POCs, paper pilots, so slideware and things like that, POCs that we've taken those ideas and actually implemented something, pilots that we've taken that and put live data or sanitized customer information in and tested and validated the case, and all the way through to production implementations. Today, this stuff is actually going into production, and I've been very surprised at sort of how quickly organizations are now interested in rolling things out and putting these things into production. Primarily because the technology is getting there, also because they have some specific issues or challenges that they may have, and they're looking to address them by using this technology to gain a competitive advantage. So this is an inventory of different things that we've implemented in various degrees, all the way from sort of conceptual through to production grade implementations. On the left-hand side of this, you see sort of all the financial services use cases, from payments to trade finance, which is a very, very good area for this technology. Insurance, which is also a very good area as well. There are lots of applications in the insurance space, and capital markets, where much of the investment initially went into to get this technology off the ground. So lots of the big banks and so on have looked at this. Property management, there are some land registries in some countries that are putting the registry of title deeds to properties on the blockchain, primarily because today they have a paper-based or even a computer-based system, but they want to make sure that the database itself is not corrupted or corruptible by a database administrator. And so you have cryptographic signatures, title deeds on the property, and a full auditability of everything that's ever happened with that property or asset. And so there are some countries that are putting property on the blockchain and recording it. The one I love is the art. Artwork itself. So there's an example of a painting basically that has been tokenized. So you take a Monet, or it wasn't a Monet, but it was something else. It was a work of art that was a painting that was tokenized and into a number of tokens. So let's say 1,000 tokens, and sold. And everyone can have 1,000th of this work of art. And you can trade it in a marketplace and do various things with it, which is a very clever way to do that. Commodities as well, so gold bullion and other types of assets, diamonds and other precious metals have been tokenized because you have a way to physically tie it back to a real property. And then you sell the tokens for cash and various things that you can do with it. So a very clever way to use this technology for that. Identity, lots of applications in identity, everything from refugee tracking through to biometrics and putting birth records and birth certificates and things like that on the blockchain that are very interesting applications, and other things in public services. And there's one in there that I also, very, very, it's the black swan of the use cases. And it's the one that's identified as cryptographic voting, e-voting. We are actually implementing, from here I'm heading out to a client that I'm working on, a project where they're building an electronic voting system for share certificates for shares, so proxy voting or shareholder voting. So every company at the end of the day has has an obligation to query its shareholders on an annual basis or periodic basis around director appointments and various things. And so the way that it's done today is through basically electronic means and paper-based means. So they send something out in the mail, and they also send you something via email and so on. But there's a lack of auditability and traceability of a lot of those votes. And the idea of using the blockchain in order to do that is very powerful, because it gives the voter the ability to go back and verify where his vote was cast, which is something that no system can do today anyway. Even paper-based or any other electronic system cannot do that. So I have a way of cryptographically going back and verifying that when I voted using the system, that my vote was sent into the right sort of bucket of votes. So a very clever way of doing that, and you can use that with the blockchain. So those are a number of use cases. Please feel free to ask me at the end. I'll leave some time for questions, but there's a lot of good examples of different use cases. So I sort of talked a little bit about this in the previous slide, but there's a lot of projects around the world that are popping up. This is by no means a sort of exhaustive list. I sort of lost track of everything that's been going on, but I wanted to give you a perspective of this from a geographic point of view. Lots of stuff in Europe. There's a lot of POCs, and people are sort of, companies are sort of kicking off sort of projects in Scandinavia, in Europe, in Southern Europe, in France, and other countries. In Asia, there's a lot of stuff that's going on. South Africa, interestingly, and North America as well. So lots of stuff that we've been involved in. Pilots that then take a lot of those ideas and actually combine them with customer information to create sort of a working prototype, a pre-production pilot. And those pre-production pilots are intended to validate the business case, validate the technology, and so on. And then, interestingly, there's a lot of things that I'm seeing around production-grade implementations. And those production-grade implementations are sort of the beginning of this just transformational change. And they happen to be, in my opinion, they're happening in places where you least expect them. Because I guess there are either systemic challenges, problems, issues in the economy, or issues with specific challenges that they may have, and so using this technology allows them to solve it quite effectively. So, is this stuff mature, right, at the end? By no means. Every time I put this slide up, I always ask myself the question, when is this stuff going to really be mature? And I think 2025 is probably the year. That's the best of the prediction. As we're getting closer to it, we can predict it with more accuracy. But what I mean by maturity is really the ability to use this technology as an alternative to traditional IT systems. And they are equally viable solution technology that is maintained, supported. It's sort of been industrialized and secured and so on. So last year, at the end of last year, I was working with a bank, and they surprisingly did something that I was very shocked about. They turned around and went from talking about this as a project to jumping straight into being asked to actually put it into production. And I didn't expect that to happen last year. And what we're seeing now is in 2016 and 2017 are going to be the early adopters. Those organizations that are going to make that bold move and say, actually, I trust that this technology is going to get there, and I have some specific business challenges that I want to solve. Let's apply it to this specific area, and let's roll it out. So we're getting those kind of organizations coming up, stepping up, and doing this. So this stuff is happening, right? So really happening, and it's happening in different places. In the next couple of years, it'll be more about growth, industrialization, securing, scaling, and so on, and standardizing as well, because there's different technologies. And then beyond that, it'll be sort of maturity of this technology. I don't think blockchain or DLT will be around in that form in 5 years' time. It'll probably be combined with something else, with RPA, artificial intelligence, other technologies that make a platform. I don't think by itself it is a component of something more strategic and of value. So by, I guess, in a couple of years' time, maybe it gets bundled into that and maybe goes away, but it'll be part of something everywhere that you'll be using everywhere down the road. So I want to show one slide because I think this is an interesting one. We worked on this with a central bank, a very, very well-known, very large central bank. And the idea of this was really to discuss when is the technology tipping point. You know, obviously you guys know what tipping point is, but what's the event that's going to say, actually, this technology has taken off? And we locked it down into two sort of areas. One where we have a successful adoption of a sort of a clearing and settlement system, and the next one is the virtualization of fiat currency. The first one, I say we're getting very close to that. We're not there yet. I think it's sort of ish now, but we're close to it. We're not that far off. The second one is really the one where I believe this will be the game changer. And I talk about that because we give examples of tokenizing assets and use cases of gold, property, share certificates, and so on. But what we miss is the fact that today people, always want to pay for things with money at the end of the day, or they want to get paid in money. And the only cryptocurrency that's currently available are things that are not sort of issued by entities that are trusted by central banks or governments or people and so on. They may be trusted, but they're not issued by those organizations. And we've been talking to a lot of central banks around the world, and I believe that we're very close to seeing in the next couple of years sort of the virtualization of fiat currency. And I know that there are a couple of them that have been looking at issuing this and doing it pretty quickly. When it gets into sort of out there, I think it'll be a big game changer. Why is that transformational? Because finally, at some point, you now have taken the value of using something physical, like I can give you cash, and, deliver it to you in hand. And you have it's instant settlement because I've given it to you, now have it. Now we have electronic means of doing this, but it's not the same thing because it's just money that's represented in some ledger. When I can do the same thing with cryptocurrency, then that's a complete game changer because now I can settle a transaction in real time and I can do it in a single atomic transaction, as I mentioned before. So this whole concept of tokenization and moving assets amongst different participants will actually take off when this takes off, when this gets implemented. So it's a bit of an advanced concept, but I think it's an interesting one, and I've been working with a lot of organizations that have been focusing on this. So DLT, blockchain and DLT architectures, we have methods and stuff. We're fantastic at developing these things. But the idea is that we actually have architectures behind this. So this is obviously a very technical group. There's a lot of technology sort of behind all of this stuff. Everything, as you can see here in terms of the different architecture components, from the security aspect of it through to the operational aspect of it, virtualization and various other components. The whole idea behind here is that you have many different flavors of blockchain and DLT technologies. It is an area that is actually quite complex, hard to keep track of all the developments that are going on. There are also, as you start industrializing and putting things out there and running it as a proper service or operation, you need to consider a lot more than the basic stuff that is being currently discussed. So the whole idea here is we've taken sort of a traditional architecture and mapped sort of how blockchain and DLT fits into that. Again, quite detailed, but an important part of sort of making sure that you deploy this properly. The other slide is really around sort of the requirements, and I do want to the non-functional requirements that you need to consider as part of a deployment. Each one of these aspects of it, I'll talk a little bit about some of them because I have some slides that a little bit later that discuss some of the solutions out there. We've been looking at how to industrialize blockchain implementations ourselves. The reason for that is it's when you're working on a POC or a pilot, it's a very different thing than when you're working on a production grade implementation for a cross-border money movement system for a major regional bank. Right, so the latter has everything around security, scalability, SLAs, operations, change requests and change management and everything that you have to consider as part of a deployment. And this is sort of the maturity of this technology. Now you need these kind of things, otherwise you are not going to be able to deploy them properly. You're going to be able to play with them, but you're not going to get them out there and deploying them as an architecture. So availability and reliability, and the recoverability, scalability, privacy of transactions, and so on, and ultimately performance. Each one of those aspects and dimensions have some very specific implications for which solutions you pick, how you deploy them, how you architect the solution, and at the same time, how you operate it as well. So other things to consider as well are sort of the business continuity. There's a couple of different key principles around this: continuity management, adaptability, flexibility, and the information security side of it. So I come from an information security background, so all of these things are very critical. The one thing I do want to say before I get into some of the other slides is the concept that security is even more important in this context than it is in other environments. Not to diminish or take away from other systems, but when you start using a blockchain or a cryptocurrency or a distributed ledger, it's a very crypto-intensive system implementation, and the whole thing about it is that you're managing lots of private keys and cryptographic keys. So by definition, it's all about the crypto, actually. And information security is a very critical part of that. So how you protect those keys is fundamental, because if you lose access to the key, you've lost the asset. In today's systems, you usually have to log into some system that gives you a privileged access management to give you access to some other back-end system, and then the money moves, and then you can recover it because the bank that sent it has a fallback mechanism and can roll back the transaction and do other things with it. Well, in this world, the key is the asset. So if you've generated the key incorrectly, if you've shared the key or the key's been compromised or whatever, you've lost the asset. And it's not that obvious because there's a lot of very specific types of attacks that can take place on how you do this kind of key management that can compromise the entire system. So security is a very big concern in this whole area, and it's something that you need to consider as well when you're deploying these solutions. I'm conscious I want to give enough time for some questions at the end. These are sort of the functional areas. I'll skip this a little bit. I do want to talk about, okay, so I did mention this before. So security and scalability remain key sort of issues. I'll spend a little bit of time on this because we actually have developed a solution around this. It's something that we made some announcements back a couple of months back. This is a technology that I was working on actually for well over a year. I've been thinking about it for a couple of years. How do you actually protect blockchain implementations using sort of bank-grade, government-grade crypto devices? And we worked with a solution provider, Talus, to actually do all the crypto key management on a hardware device. And the whole idea behind this was to actually perform all the crypto operations inside this device. So this is a device that is used by many different banks and governments and so on. So it's certified and used by them, but it doesn't necessarily work directly with lots of out of the box with blockchain solutions that have been implemented, specifically because the kind of curves and algorithms that are being executed on this device are not standard algorithms that are being implemented by some of the blockchain solution providers and technologies out there. So we spend a lot of time doing that kind of level of integration, and the whole idea is that if I can simplify a year's worth of work into a couple of different, in a couple of sentences, really, to be able to actually do secure key generation inside this device, and to be able to manage the keys. So signatures, or the signing keys, never leave the device. The device basically contains all of the private key material, and for the special elliptic curves that are used by blockchain implementations, they never are exposed to the outside world. So your assets are basically secured inside a device like this. So there are different types of threat vectors that are out there that can compromise you. So next, this is the architecture. We have actually a working prototype. If you're ever in London, let me know and I can show you how this thing works. It basically have a mobile application that we developed at the top. We applied for patent for this solution, but in reality what we want is to make this open standard for lots of other organizations to sort of tap into. But the idea is that at the very, very lowest level, you have sort of all the hard crypto key management functions that are being performed. And then as you go up, you have more functional capabilities, and then build out sort of the business applications at the highest level. So application developers don't have to be cryptographers, and that you know that when you're using these libraries, you can actually ensure that the right calls are being made in the right way, that you're generating keys and doing things. So this is an architecture of the solution, but this is just an example of the prototype. So I have 5 minutes left. I guess maybe take some questions and take it from there.
Lately, there has been a lot of information about fake news and so-called alternative facts. And do you see that this would be a feasible technology and realistic to kind of protect the integrity of information?
Absolutely.
In the future?
Yeah, absolutely. Very, very good question, and something that, especially around the data mutualization and the data sharing aspect of it, we have been actually working on a couple of different solutions around taking sort of information from the source, trusted participants that would provide a method of signing and disseminating information in real time or near real time, to a number of authorized users. That could be open as well, so it could be the public, but at the end of the day, you know that it came from a trusted source and who provided that information and where it came from. And the mechanism of dissemination is not centralized. Here, what we're talking about is completely distributed. So even if half of the network went down, the other half would continue to work, or there is no central trust in this. It's basically a distributed trust model, which is actually very conducive, or there's a lot of principles that are very transferable from a news dissemination into this model, into this world. So absolutely, a very good use case for that. That's not the first time I've heard that, and people have asked that. A lot of fake news out there, so you want to make sure. Any questions? Any other questions? I'm sure you have questions. This couldn't be the first time you've seen a blockchain presentation.
I think it's excellent presentation, but how taxing is the blockchain? Like, you have these crypto challenges for every transaction, so it must take a massive amount of processing power. Yeah. And it might be slow, because always when you have more security, things get more difficult.
Yeah. Also a very good question. No, I didn't get into the specifics of the consensus mechanism. So when we say a transaction gets recorded and placed in the ledger, something happens, right? So in the Bitcoin world, mining happens. So 10 minutes of mining and the creation of blocks and a whole bunch of rewards get issued on the back of it and so on. Primarily, or specifically, because it's an untrusted network. And so the way that you build trust is by creating a problem that is very big, right? Computationally intensive problem, which is mining, and that also takes time. So that, in order to commit the block in that case, it'll take 10 minutes. In a model where you don't have the same kind of trust issues, right? You can create a consensus mechanism which is much more conducive to a closed network, or a permissioned network, permissioned blockchain implementation. So the trust model in that case doesn't have to be a hard cryptographic challenge that takes time and costs money and effort and so on. It could be a different kind of consensus model. We can agree that if 51% of us agree that this is a valid transaction, then it's a valid transaction. If 8 out of 10 of us agree, then it's a valid transaction. If we do a round robin and we say, actually, the next one that gets a, so there are different types of consensus mechanisms, and they all have performance, speed of execution, and other attributes as well that allow you to deal with the timing concern or question that you just raised. So if you want near real-time execution, you may create a consensus model that says, when I ask the nodes to validate this transaction, I'm willing to live with a 60% response, right? And then if a couple are down, then I get the response pretty instantly, and then I commit the transaction and I roll on. So you get this concept of range from 10 minutes or whatever that's happening today in sort of cryptocurrencies like Bitcoin, through to other types of other types of consensus mechanisms that could be near real time. So time is not really an issue as long as you have the right kind of governance and consensus mechanism.
Do you think that blockchain could be like this internal tool, like you have this internal network at the company, or do you prefer it more like intermediate between the business entities?
So that slide that had the 5 attributes, unless you tell me that inside the company nobody trusts each other and you have a different problem. Could happen. Does happen. It should take those parameters: multiple validation, multiple control points, multiple actors that are involved. It does happen with large corporates that are federated, international organizations and so on. But the use case is really about building an ecosystem of trust in a distributed fashion. So it begs the question. I don't want to say no, but I'd rather know what the use case is, because there are a lot of applications of it, specifically for things like reconciliation, right? So we've implemented Nostro account reconciliation on the blockchain. Nostro accounts are accounts that are held for money movements between, and this is all within one institution. It's cross geographic boundaries. But we're using it for optimizing reconciliation. So a very specific use case. It's more of a back office function. It's not the full power of what this technology can do, but equally applicable and useful in that kind of context. So you could do it. It could be a use case, but I'd like to know more about what you're thinking to see that.
I was thinking about like the R3, the blockchain cooperation between the big banks. It's like in a sense internal blockchain.
Yes, but the banks don't trust each other. So.
Oh, okay. And same is the Mars blockchain for the shipping containers.
Yes. So in that case, it's more about trade finance and tracking. So in that example, it's great because in the shipping business, you'll know that you're shipping something from Hong Kong to Helsinki. At the end of the day, it'll pass customs, it'll pass insurance providers, it'll go through different shipping companies. So the whole process is actually very complex. And there's trade finance, there's letters of credit, there's all sorts of parties involved in this whole mix. So it ticks all the criteria actually, because it has multiple parties and multiple actors involved in that. So in that case, it's great, but they're as much affected by what's happening outside as they are inside their own business at the end. And actually, I would argue that it's more about the outside than what they're doing internally in that case.
Yes, I was thinking more about like, do you have these nodes, and you have the consensus between them. So if you have enough computing power, you can overthrow the old consensus.
That's interesting. The computing power conversation should be about more around the mining aspect of it. So in this case, when we talked about consensus mechanisms, you don't need to do mining, and the computing power argument goes away, because in that case, it could be just about proof of stake or prove that you are an allowed participant in here. You had a question, yeah?
Yes.
So could you mention something about the identity networks that potentially emerge from blockchain, like Sovereign or other sort of competitors to these sort of global players like Facebook and Google, who kind of rule with the consumer identities, and you use those to log on to different sites. So does Sovereign or other similar blockchain-based or DLC-based identity networks stand a chance?
I'm just trying to understand the question. So is it about sort of the technology providers? Or
Sovereign is an open source thing. Evernum, I guess, is the company who are sort of the founders of that technology, and I can't remember what they use, but it's a distributed permissioned ledger based technology for claims that can be issued by actors in that network, and then identity is sort of always a sort of combination of those claims by governments and banks and whoever.
So I would I would answer that question into 2 parts. The first one is around the provision of a service and the usage of the technology. So let me do the technology part first. In my humble opinion, I don't think anyone's going to make any money out of the blockchain technology stacks that are going to be out there. I think this has to be open source. It has to be accessible by everyone. it draws almost exact parallels to what you're seeing with the internet today. So in terms of what's happening with this Hyperledger Fabric and the whole Linux Foundation project, even Corda has open sourced their technology, even Ethereum is all open. So all of these sort of technologies that are out there are all open sourced, and I believe that's the right model. It has to be that model. So from a technology point of view, I think the ones that are proprietary will probably not be as effective. They may have a niche market, but the whole idea is that these technologies that I've just described, the three sort of major ones, have some very distinct attributes behind those, and I think those are going to be the predominant players in the market in the next thing. But they're not owned by anyone. This is open source at the end of the day. And the whole idea is that people are building solutions on top of these open source technologies, much like, if not identical to, defining what the internet protocol is. This is what the project is about. Actually, all the people that are working on this are pretty much laying the rails, right? The rails will be free, but they charge for the cars on top of it. So, so from a technology point of view, that needs to be open source. And again, I don't think there's any dominant player that will own that part of it, because they can't charge for it. As a service, it's a different story, because the service is a pay-to-play type of thing. You can set up your own blockchain, and you can do whatever you want with it, with the open source technology. But if you're plugging into somebody else's service, and you're a bank and you have to use somebody else's blockchain solution, then clearly you're governed by those rules. And so in that case, you have to, there's a commercial angle to that, of course, and that's a bit different, of course. So if you want to set up your own, the tools are all there, and that's what we're seeing a lot of organizations are doing. They're investing time and effort and resources. I was actually so surprised. I was talking to a client, and I found out in one of the first calls that I had that they had 25 people working on blockchain in that one organization. I was like, what? 25 people? Where did you find, first of all, where did you find 25 people, number one, on blockchain specifically? And then, and they weren't even a blockchain company. They were just, they were actually in the exchange business, and they had spent so much time. So they've been investigating, scouting, downloading stuff, implementing solutions. I was like, wow, this is incredible. I never expected that. So they're building their own solutions on top of this open source. I'm not sure if I answered your question. Okay, thanks. Any more questions?
At least for the Bitcoin network, the kind of the mining is great stuff, so that you don't have to have trust between the parties, but otherwise it's very energy intensive. So is there any other kind of these consensus mechanisms that are kind of trust free? That you don't have to have trust, but they are kind of a bit more faster or cheaper
Than mining.
Than mining. Well, when the proof of work kind of.
Proof of work. So I didn't, as I said, I didn't talk about specifically the different type of consensus mechanisms, but proof of work and mining, by definition, is one that's used in a completely untrusted network. Yeah. You need to have the mining aspect of it when you're using it for an application like Bitcoin, because no one trusts anyone. And actually the size of the prize is enormous. It's billions, right? So if you can compromise the network, you have all these assets that have been at your disposal. So you have to create a big cryptographic challenge and mining challenge and reward mechanism to support that in order for you to create the level of trust inside. Alternative types of consensus mechanisms are going to be very dependent on what it is you're protecting. How big are your adversaries and potential growth of computation? But the question then is it an open network or a closed network? If it's an open network that anybody can join, then you have to have the right kind of consensus mechanism, like a proof of work or something like that, to protect it. If you have a closed network and you have a semi-trusted environment, then you define the governance rules, you define the consensus mechanism, and then that problem sort of goes away.
Okay, thank you.
Thank you.
You're a very knowledgeable guy, and I think there is a lot of people that will come to you after this and ask a few questions. Anyways, we are having lunch the next, and there is salted reindeer, and for vegetarians, salted pulled oats. So after the lunch, there will be keynote number 2 from Max Fernanov, and then we will be back here to listen Josh Naylor from Unity and how to use virtual reality in more business-like context. Thank you.